Hey everybody, this is Larry. This is day 31st of the May Leetcode Day Challenge, the last day. I think I said that yesterday and I was like, whoop, off by one. Hit the like button, hit the subscribe button, join my Discord, let me know what you think about today's problem and stuff. Yeah, I hope everyone's having okay last day of the week. Well, now. Man, I just cannot do days anymore. Last day of the month is what I mean. But hope everyone's doing all right. It's Thursday or maybe Friday, depending on where you are. So weekend is here, which is exciting. I have to do some stuff, but yeah. What was I gonna say? Yeah. I am very tired today. I ran 14 miles, 15 miles just to see how my body handles it, and suffice to say, not well. I've been drinking a lot of liquid since then, but still very tired. But we'll see how much I can get out of this problem. Today's problem is 260, single number 3. Given an integer array nums in which exactly 2 elements appear once and all elements appear twice, exactly twice, find the 2 elements that appear only once. You can return the answer in any order. So this is a variation of the classic problem. I don't remember this one per se, but you can probably reconstruct it, right? So the thing is that with the XOR idea, which I don't know the Leetcode problem number, but there was a version of this where only one number appeared once, and you take advantage of this trick. I know that I hate saying I hate that people call a lot of things a trick, but this is a very particular trick for a very particular type of. It's not even a type of problem. There's like 4 problems that uses it, but that's the idea, right? The idea is this XOR trick because basically if you XOR 2 numbers, you go to 0. So then now you can if only one number appear once, then everything kind of cancels out. So then now you have one answer. It kind of reminds me a lot of physics class, to be honest, in uni, because I think in uni well, physics is very hard, and a lot of problems don't have solutions, right? Or like analytical solutions. So in intro physics, what happens is that there are a lot of problems where conveniently by argument of symmetry, a lot of things cancel out, and you have like this very simple thing at the end, or a 0 or something like this, right? And it's not quite that, but this is the same idea of XOR, right? So you have 2 numbers, you XOR itself, and then and then you have one number left, and that number is your number. This is not that problem per se. This is one level more difficult, and now you have 2 numbers, right? What do I think about that? How do I handle this? Well, I mean, we could take a look at some. Well, one thing that I would say is that given an XOR solution, every bit is independent from each other, right? Meaning that so this is something that, at least for competitive programming, just because XOR problems come up a lot, is something that you probably should be thinking about. It's not really a trick per se, even though, like I said, a lot of people call everything trick. Everything you don't understand is a trick, and everything if you force yourself to memorize it without understanding it, then yeah, it's a trick. But if you actually understand a lot of these ideas, then it's not tricks. They're just ideas, and ideas that you can apply in different ways in different times, right? And for this XOR, the one critical idea is that every bit is independent, right? So that, so for example, I'm looking at this problem, and I go, okay, well, we have a 5 and a 3. What does that mean? I don't know what does that mean, right? But like it's hard to kind of for me to look at that and have an answer. But here's another idea, right? We have negative numbers. That changes things a little bit, but I mean, let's stick to the positive numbers for now. I mean, I know that negative numbers are implemented in two's complement, but nonetheless, we'll get into it afterwards. But okay, so then now let's say we have. So that means that there are 2 numbers left, right? So what does that mean? that means that, or there's two numbers, we're given one thing, right? I mean, the thing is that you can like enumerate stuff, right? For example, if you have two numbers left, so let's say, okay, so yeah, so looking at each bit, we only have two possibilities, right? The number for one of the bit, it could be 0 and it could be a 1. What does a 0 mean? That means that both numbers have 1, or have a, well, let's start with 0. 0 in this bit, or a 1 in this bit, right? And this is both numbers are different. So one of them is 1 and one of them is 0. Okay, now how am I? So that is an idea, right? But what can we do to? Well, I mean, trying to think. As you can tell, I don't memorize these things, so I don't have an idea. I mean, the other one, I don't even think I've memorized it, but it is a very common brain teaser thing that people used to do. But in this case, they're both ones. But how can we? Also, I think the linear time thing is a little bit awkward, but that's besides the point. Maybe we'll see what the actual thing is, because I don't like to count bits as a constant, but that's, so some people differ in how they mean it. Man, I'm not gonna lie, I am a little bit stuck. So that's why I'm pausing and trying to think. Okay, so then now you have this XOR thing, right? And you XOR everything again, then now it's just 0, so that doesn't do anything. But if you the other thing is that now you have A XOR B or whatever. So if you find one number, then you have to find out the other number. So then you just have to figure out a way to find one of the numbers, right? And that's the part that I somehow am blanking out on, to be honest. Okay, I mean, I think one thing. Well, I mean, one thing that is true is that if both numbers. Okay, so so let's rewrite this a little bit, right? So we're trying to find a B. We know what A XOR B is, right? The thing is that we know that by definition A is not equal to B, right? So that means that at least one bit has to be different. Right? Which is, yeah. So is not equal to 0, right? And then now we can actually, I think that's enough, right? Because then now using that bit, we can just look at all the numbers that have that bit as 1, and then we can figure out what that number is. Because again, so now we're taking a subset of the nums where, let's say the ith bit is a 1, right? Doesn't matter what the ith is. And we're taking a subset of the nums where the ith bit is a 1. And so by definition, all the other one cancels out, so then you get one number left. And that number is, because the ith bit is a 1, it only gives us this subset of numbers where ith bit is them. So let's add in a thing where, so only one of A, B is inside this subset, right? By definition, because, and then from then, you can get one of the number, and because you know what A, X, or B is, then you get the other number. Let's play around with this. I don't know how that affects 2's implement. I think that shouldn't change anything. We don't even care about the number, it's just about bits. So as long as, with 2's complement, I don't think it changes anything. So yeah, so then now we have X is equal to 0, say, for X, terrible. Let's call it total. Because I think about XOR as like an operator, right? So then now here again, total is equal to A mod B, or XOR B mod B, XOR B. So then now, we can do something like, we find the first bit that is, doesn't even matter which direction we go, I don't think. And the numbers go up to the 31, so let's just go to 35, I don't know. Well, I'm just lazy to kind of worry about 31 or 32 or whatever, especially with negative numbers. And of course, in other languages, you have to be a little bit more careful. But yeah, if this is greater than 0, then we break, right? And this has to be true for one of the numbers just by the definition of what we said, right? Because A is not equal to B, or A XOR B is not equal to 0. And then now we go for X in nums. If X is greater than 0, then we count in this set, and subtotal, say, is equal to 0, right? And then now that is going to be one of the numbers, and then so that's it. So then you have subtotal and total XOR subtotal, right? And very rusty on stuff like this. Let's give it a submit. Apparently I did it 3 times, but the last time was 3 years ago. I really did not remember how to do it. How did I do this? I guess I have the same idea. I just get the lowest significant bit. I might choose the lowest one, but it doesn't even matter that much. No, I did it in straight C just to, I don't know. How did I do last time? I guess I did the same way. I had to really think about this one, to be honest. Yeah, I mean, I guess I came to the same conclusion eventually. The way that I thought about it is a little bit different. I want to talk about bitwise operations very quickly. But XOR, you know what XOR is, probably, hopefully. If not, then this is, they don't really go over. Just Google XOR and the properties and play around with it. I mean, like, me explaining it is not really that interesting. I think a lot of these bitwise problems, you have to play around with it and playing around with all these ideas. I think once you gotta get the feel about it is a little bit easier. Otherwise, as I was saying this on the chat today, on the Discord, I think a lot of people, the hard part about the harder problems is that understanding is not doing, right? Um, you have to figure out what or how to learn what you want to do, right? And understanding is not doing. You for that's the hardest part about problem solving is that I think a lot of people confuse understanding the solution. Your goal is not to understand solutions and be able to explain it. Your goal is to be able to reproduce these answers and solutions from reading a problem. Hence, problem solving. You want to solve problems. Understanding is not enough. You have to be able to do it again. So you have to play around with all these problems and keep going until you are able to do them. And I think this is where I always say this. The border is about like Q4 or something like this. I mean, it's not a hard line, right? But I think for a lot of people, and it's true, you can't get very far by just people talking about pattern matching and patterns and tricks and stuff like this. But but once you actually figure out how to solve problems, that's how you're able to break through that mark and then keep going. And a lot of that is going to be tough, but but that's the thing that's in demand. That's the thing that is not AI-able yet. Maybe, I don't know. At least not given the current ways of just machine learning with linear algebra and what should we call it? Cellular automators and stuff like this. But yeah, maybe I'll do another video specifically on that. But keep that in mind. And yeah, that's all I have for today. That's all I have for this one. Well, that's all I have for this one. I'll solve another problem today. So thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. Let me know what you think about this tired Larry all the time. Maybe I need to take a break from all the exercising. But yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.